what you come up with?
One-eighth.
It is 1/8. Good. Okay. This is maybe more. All right. I think maybe we should work on some of these. All right. Given the function, find the constants a and b such that the function is continuous and differentiable at x equals 1. Does this look at all
Um,
familiar to you?
yeah, but I'm gonna be honest, I don't know how to do it.
Okay, so the first thing is you put 1 in for x in
Okay.
both equations. Just x. Could you do that and tell me what? And then 1 is going to be on the left side of the equal sign and 1's going to be on the right.
So 3 plus a squared plus b.
It'd just be a plus b. The x is yeah, it's 1 squared, 1. A times 1 is a. Okay, so the
Okay.
problem with this is that it's one equation, two unknowns. That's no good. So now you have to take the derivative. So give me f prime of x.
1 and then 2 ax. That's
Okay,
it.
now
Yeah.
do this. Now do the same thing. Put uh, 1 in for x.
So for the first one, it's just 1, and then 2 a.
Okay, solve that for a. Put that back in. Determine the values of
So 3, 1/2 b. So b equals 6.
a is 1/2. A is one
Oh
half.
yeah.
B is not 6. Try that one more time.
Oh. um. Wait, don't we multiply both sides by 2? Oh, it's plus
Um,
b.
yeah, plus b.
Okay, that's my bad. So 2.5.
Okay. Yeah, b is 2.5. Okay, so that's kind of your pre-derivative stuff that you might see.
Okay.
There's lots of other stuff too. I mean, I'm just sort of throwing that out there as a possible thing here. All right, so here's another problem. So you are allowed to use derivative rules for
Okay.
these.
Find the value. Okay. What's 1 to the negative 1/2 power? How do I
So
figure that out?
one to any power is 1.
Oh,
Doesn't
okay.
matter whether it's 1/2 or pi or it's always 1.
So f prime of 1 equals 1.5.
Give me your derivative. That doesn't sound quite right.
I did 2x minus 1/2 of x to negative 1/2 power.
Okay. That is correct. I'm sorry. You said 3/2. Or 1.5. Okay. Yeah,
Yeah.
misheard you. All right. Now the real problem here is actually asking for the tangent line. So
Okay.
there's a couple of ways to do that. Choose the way that you like in terms of how you would write the equation of a line.
Um, just like the y, like
So this is not the best option, but this should be the most familiar. The best
Yeah.
option is point slope form because you can have a point. Your point you would get by putting x into this equation to get y. Then you've got an x1 and a y1. You already have the slope. The slope is 3/2.
Yeah. And I could just plug in a value to the original, right?
Yes, that's how you find it.
Okay. I'm gonna do 1. Okay, so y minus 2 equals 3/2 1. Okay, so I did y minus 2 equals 3/2 times x minus 1.
Okay, perfect.
Okay.
All right. All right. So I'm gonna put something in front of you that I'm pulling these from college exams, and depending on the university, they can go really crazy with stuff. Um, there is something here that you don't need to be able to calculate this, but just gonna put this in front of you. See if see if you can figure it out.
Um, I don't need the z equation, right?
That's right.
Okay.
Good eye on that. That's important.
So the 2 can come down in front of the lx, right?
Uh,
Or ln.
no, no. So yeah, good question because like the better way to write this is this. What you want to do is if it was natural log of x squared, that is 2 natural log of x. But
Oh.
you're squaring the whole thing, although it's really unclear how it's written. Surprised this made it through.
So how would I do that then?
Power rule first, then chain rule.
Um, so 1 over x. Oh, okay. Okay, so 2 ln of x over x. And then plus negative e to the negative x. Or minus, either one. And then dx times dx.
Yeah, so no, you don't need any more than this because you
Okay.
have you're not doing differentiables or other stuff. Um,
Okay.
all right, so let me find another problem here. Okay, so this one I want you to find the first derivative of.
Okay. Okay, I did f prime of x equals 3x minus 1 times 3 times e to the 3x plus 3 times e to the 3x.
Okay. Now could you set this equal to 0 and solve for x?
Um, no. I would just actually never mind. These can't.
No,
So
no calculator. You would
these cancel
factor out
out.
you can
Oh,
factor them out, and then what's left over you set equal to 0.
e to the 3x 3x minus 1 times. Okay. So x equals 1/3.
So did you get 9x minus 3 plus 3 in here?
I kept the 3x minus 1 and the 3 separate. And then I subtracted 3 from both sides.
You got to factor out the either 3x or cancel it. I mean, you have to, like, what's left over. It doesn't really matter how you look at it, but what's left over is this plus the 3.
Yeah, that's what I did.
Okay. Subtracted 3 from both sides.
Yeah.
Okay.
And then divided by 3. Oh, that's equals to 1, not
Okay.
0.
Keep going.
Um, x is undefined, right? Or is it infinity? With
It's
0.
neither. When you
Oh,
when you add one,
what?
when you add one, it's a sharing problem. When you divide by 3, you have nothing to share but 3 people to share it with, so they don't get
Yeah.
anything.
So it doesn't exist? Or is it
Zero,
0? Oh, it's
zero, zero,
0.
zero. Yeah.
Okay.
No pizza, and 3 people that want pizza, they don't get any.
Okay.
It's very sad, but that is the reality of this. All right. Let's do. Have you done? You guys should have done this by now, but I don't. I don't know if you've done absolute mins and maxes.
Yeah, we have.
Okay. So in a closed interval like this, which is the case for a lot of these min max problems, is you want to first evaluate each endpoint,
Okay.
and you can use a calculator if you really want to. It's fine with me. But give me the numbers, please.
Um, for the negative one, it's -7.
Okay.
And then 1.
Okay. So right now it looks like that's the -7 is the min and the 1's the max, but you next have to find the derivative
Okay. So
and then
x
set the derivative equal to 0.
12x squared minus 6x and then equals 0.
Yep.
And then
So there's 2 places where it equals 0.
wait, how do we know that?
No, well, I'm helping, trying to help you out
Oh,
here,
okay.
so you're not surprised. When I say, where's the other one? You should factor out a GCF.
I did 6x,
Okay.
and then you get 2x minus 1,
And set
and
both of
then
those equal to 0.
1x equals 0, and then the other equals 1/2.
Okay. Are those in the interval? Are those between -1 and 1?
Yes.
So now you have to compute each of those.
Oh, so we plug those back in?
Yeah, into the original.
Okay. So for 0, f of 0 equals 0.
Good.
And then Negative 1/4.
So it actually didn't really help much, but because like but now you can actually say which is the max and the min.
Okay, so
The other,
negative 1,
go ahead.
-7 is still the so negative 1, -7 is the min, right?
Absolute min, yeah.
And
And what's the
then
absolute max?
1 and 1.
Right. Now you could make a really quick sketch of this. -1, -7, 1, 1, 0, 0, 1/2, -1/4, and that'll tell you where the relative mins and maxes are.
Okay.
So this is a relative max. As you can see, it goes like it peaks there. And then this is a relative min.
Okay. I do remember
All
getting
right.
one of the problems like this on a test wrong.
Very, very easy to do. Yeah. All right. I got okay. So this is an implicit derivative problem. This one's pretty challenging. Do you want us to start off with an easier one before we do this one?
Um, yeah, because I'm gonna be honest, I don't really remember how to do this.
Okay. Y squared plus x squared plus xy equals 1. Okay. So implicit derivatives. Um, the derivative of y squared, you treat it like an x. Like what's the derivative of x squared?
2x
So this is 2y, but whenever you're taking a derivative with respect to y, it's dy over
dx.
dx.
Okay. Plus
Plus,
2
what's the
2x.
derivative? 2x. Now this is
And
where
you
it
don't
gets more complicated. Product rule question.
no, you don't add the dx. You don't need the dx for the 2x,
Not
right?
for this, no. Nope. And the reason is y is a function of x, and x is a function of nothing.
Okay.
So you don't have to worry about it. This is product rule though. So let's say you keep the first and take the derivative of y, that would be 1 dy dx, plus the derivative of x is 1 times y. So the derivative of this is this right here equals 0.
Okay. Equals 0.
Now,
And then
you're gonna undo. I'm sorry. You're gonna move anything that's not a dy dx to the other side of the equation. Subtract 2x. You're gonna subtract y. So you have 2y dy dx plus x dy dx equals minus 2x minus y.
equals. Okay.
Okay. And then you factor out a dy dx.
So 2y plus x.
Yep. And then you divide by that on both sides.
Okay. And do I have to
And that's your
simplify
final.
anything? Okay.
This one does not simplify. There's a few other ways to write it that could be equivalent, but I think this is fine.
Okay.
All right. So if we want to go back up to this problem here,
Okay.
I'd like you to just try taking the derivative right here. You don't have to solve for dy dx here. Let me just check that first part of whatever you do.
So 6y squared dy dx minus, oh God, 56x xy plus 8x to the seventh power dy dx
So make sure
equals
you
0.
distribute that negative before to both, or that negative to both.
What do you mean negative? Oh, the
Well,
negative 8x.
yeah, yeah. I also didn't hear the exponent the first time. X, that's 6. Okay, on the right hand side, 4. Anything else?
Dy dx.
Okay. So from here, there is no more calculus. It's just getting everything over. Typically, dy dx is on the left, non-dy dx is on the right.
Yeah.
Do you want to try simplifying this? There's no calculus, so but
Um. Okay, I did 6y squared. Oh wait, is it 9?
I believe it's a 9. 3 times 3, 9.
Oh yeah, it's definitely 9. 9y dx minus 8y dx, or 8 dy dx minus 4 dy dx.
Are you gonna do the? Are you giving me the whole thing, or you just give me an intermediate step?
The intermediate step.
Okay, keep going here, and
Okay.
give me the final answer.
Okay, final answer dy dx equals 56x to the 6th power y all over 9y squared minus 8 minus 4. Oh,
It's yeah,
it,
8x to the 7th.
uh,
Okay, it is a really difficult problem. This is from MIT, by the way. Yeah, so why it's so difficult? Um,
yeah.
Now this part we don't have to find the equation. You can just give me the slope at 1 comma 2. But you got to be comfortable with putting these numbers back into.
Oh wait, for this last problem?
Yes.
Oh shit. Okay. Um.
Let's keep it clean for the YouTube audience.
Oh, sorry.
It's a joke.
I could plug it into the dy dx equation, right?
That's right. Yeah.
Okay.
It looks worse than it is. Like 1 to any power is 1, 2 to the, it's not, it doesn't become this outrageous thing.
Actually, like I don't know what to do.
So you're
With the
putting 1
because of
in
the
for
line.
X and you're putting 2 in for Y.
Oh. Okay. And
We are
then
practicing for the real thing. So it's okay to ask these questions.
okay, minus 4. So 56 times 2, 112 over 9 times 4 minus 8 minus 4. Okay, 112 over 24.
Okay. Does that reduce?
Um, 14 over 3.
Okay. All right. Good. Good job on that. So let's take a few more problems here. Um, do you think you'll get any multiple choice questions?
No. He deliberately said no.
Those are so tough to grade. All right. right, so this is a classic sort of calculus problem. They give you a table like this.
Okay.
Have you seen a problem like this before?
Yeah.
And then they ask you like f, they tell you that h of x is f of x over g of x, and they ask you to find h prime of 3, for example, which is
Oh,
a quotient rule derivative.
yes.
So what you really have to find as an intermediate step is h prime of x, which is g of x, f prime of x minus f of x, g prime of x over g of x squared. And
Okay.
then to find h prime of 3, you're putting 3 in.
For all of that.
Yeah,
So g of x of 3. So negative, oh, wait, no. 2 times 0, which equals 0, minus negative 10. I got 40 over 16.
g though it's 2 squared on the bottom, not 4 squared.
Wait, why is it 2 squared?
It's g of 2, not g prime of 2. Or g prime,
Oh,
yeah.
so 4?
Try again.
Mm,
Negative. Oh, I'm sorry for the whole thing. Yeah, the bottom is 4, but
oh,
what's the whole
okay.
thing?
Negative 10.
-10. Okay. Okay, so here's another style of problem. These tables are great. They could give you something like this. -5 x cubed times g of x. They could tell you that this is p of x, and they want p prime of 0. No, sorry, p prime of 1.
Okay. So we're finding the derivative. So
Yeah.
negative 15 x squared times g of x plus negative 5x cubed times g prime of x.
Okay.
Okay. So negative 15 times the 1. Wait, I just plug in 1 for the negative 15x squared, right? Not
That's right.
f of x.
X is 1. That's what this notation means.
Okay. And then g of 1, 7 plus. Okay. Um, I got. Hold on. Oh, I got negative 105 plus 15, which does not seem right. Hold
That's
on.
correct. Yeah, that's correct.
Oh, it is?
Yep.
Oh. So, plus 15. Negative 90?
Okay. Very good. So the last one is the most complicated one. They will tell you that then h of x is f of, let me double check. Uh, let me, sorry, I was doing something else. F of g of x, and they'll ask you for h prime of 3.
Okay, so the composite thing. Um. So how do I split that up? The
This
F.
this is chain rule.
Oh. So to find the inside and the outside. Okay. So G prime of X, right? Inside and then
Um, yeah, I mean, this is a pure chain rule. Like, how do you take the derivative? What do you take the derivative first, the outside function or the inside function?
I usually do inside.
Okay, so that's fine. G prime of x, and then what?
Um, F prime of G of X.
Yes. Okay, that's h prime of x. Now you're gonna find h prime of 3.
Okay, so G prime of 3. So 4 times 120?
No,
Oh.
let's try it. 3 prime of 3 times. I'm sorry. I know I'm very direct. Uh, I don't mean anything negative towards you. Just the answer is very, very far off. So g of 3 is what value?
4.
4. So this is the only one where you've had to go in within another column.
Oh, I did. Wait, no.
You are right. Huh. So I'm looking at the answer here, and that's not one of them. You are correct. Sorry, that's why because I'm just looking at the answer. Sometimes I don't.
Yeah.
Oh. So g of 3 is 2 though. That's why. That's why we're both off here. Yeah, this is 2.
Oh,
So
that
then
actually
you
makes
are going to another column. So f prime of 2 is,
-4. -4.
yeah,
So
no,
negative
no,
16.
f prime of 2 is 5.
Oh, what? Oh my god.
It's easy to do. Already done it. We've already done it twice. G prime of 3 is
4.
good.
So 20.
Right. Very common to get a question like that. Um, where is the problem? Okay, so the next problem here is you're supposed to find, I'm asking you to find the inflection point. That's an ordered pair.
Yeah.
So I'm looking for both x and y, please.
So I find second derivative and set second derivative to 0, right?
Yes.
Okay. So for x, I got 3 halves.
Okay.
And
You're
then,
allowed you're allowed to use a calculator. The other one if you need to.
oh, okay. I
Yeah,
plug in
sorry.
3/2 to the original equation though, right? Not
That's right. If you put it into the inflection point, you'll get 0. First derivative, you'll get who knows what, but that's what
okay.
you want.
So I'm getting negative 59.5.
Okay.
Does that sound right?
It's reasonable. I mean, the main thing was just getting you to put some numbers back in to the original.
Okay.
All
Do I
right.
have to do anything else?
What's that?
Do I have to do anything else for that, or is the point of inflection really that?
Yep. Just check your understanding.
Okay.
Okay. Tell me the two ways that you could take the derivative of this. There are two ways.
Um, we could do log. Oh no, that's limit. We could do quotient rule,
Okay.
or we
We're
can
not
bring the x cubed up and then make it -3
I was
or
looking for a
negative.
logarithmic
Oh,
appreciation. Yeah. All right.
can we do
Um,
logarithmic? Because I don't know how to do that. Or well, I do, but like
yeah,
not really.
yeah, that was the whole point of this is that the first step is just to figure out how to rewrite this thing so that you could do it. If you take the natural log of both sides, things on the top are positive, so it's the natural log of sine x plus 1/2 natural log of 1 plus x minus 3 natural log of x. So
Um,
take a look at that, see if there's anything there that you don't like.
hold on, let me rewrite this. And we can bring the 1/2 down because it's just the 1/2 only is related to the 1 plus x, right?
Yes, it's the exponent. Exponents can be brought in front. You were asking about that earlier, and that's true.
Yeah, okay. And when we bring the x cubed up, it just becomes x to the -3rd power, right? Or what does it become?
I would, if it's on the bottom, and that's why it's the negative. If it's on the bottom,
Okay,
so this is more generally a times b to the 1/2 over c to the third. So it's the natural log of a plus the natural log of b to the 1/2 minus the natural log of c to the third.
okay. And we can bring the 3 down.
Yeah,
-3 ln of x. And then this, we do,
3 to the one
um,
third.
we can just take a regular derivative of this, right?
Yes. So will you take the next line for us, please?
Yeah. So okay, so I have cotangent x plus 1/2. Oh, 1/2 over x. Does that work? Oh, 1 plus x.
The whole thing.
1 plus x. Okay. Minus 3 over x
What about the
times
yeah, times to get some more?
um 1 over the original.
Well, this is 1 over y prime, so it's just times y.
Oh, okay.
Um,
Do I have to simplify that, do you think? Or
no,
can I,
no, but yeah, no, that's good. I mean, that was the whole point of this is okay. Let's have you try, I don't know. I mean, I don't really want you to do another one of these, but so yeah, we might as well. All right. I know these are tough, but it does seem like your teacher might give you something like this
yeah.
because why not? You know, spirit of the season. We're gonna. Oh, man, there's nothing like this on the AP, by the way. No, no. I mean, I think they give one of these, but it's not on the free response. It's just one multiple choice out of whatever 30 or 60. I don't know how many there are.
Yeah.
Okay. So first, figure out how to break this apart, please.
Using ln, so ln of x squared plus 6 plus ln of 3 to the power of 2x minus 1.
So that will come out in front.
Oh,
Very important, but it's in parentheses. But
ln of 3. Okay. And then minus 1/3 ln of 2x minus 3. And then we're just going to take the derivative of that.
yep, I heard a 3 instead of a 5 here, but it's
Oh, yeah.
5.
So 2 over x squared minus 6, or 2x over plus um
It might help to distribute the ln, and this is just a number. It's a constant.
how
Imagine
do I
if it
do
was
that?
like, so yeah, so if I wrote it like this way, 2 natural log of 3 times x minus the natural log of 3, which one has an x?
The first one.
Yeah. So it's
Oh,
just
wait,
2
wait.
natural log of 3.
That's the derivative?
Yep.
Wait, that can be the derivative.
It is
Huh.
the one over only applies if you got a function inside function.
Oh, okay. 2 ln of
How about
3
how about the last one?
minus 1/5 times 2 over 2x minus 3. And then times y.
All times y. Okay. All right. So that is going to do it for us for today. So for our upcoming, we got a lesson tomorrow. Hopefully you'll have some things you want us to work on. There's a lot of
Yeah.
problems like this. Things we didn't get to are like related rates and application problems and stuff like that. So we're going
Yeah.
to go ahead and stop there for today.